Okay, this is Unit 2 in our course. It's entitled Matter and Measurement. And we will be going over the measurement part of the course first, and then we'll talk about matter and divisions of matter and get into chemical and physical changes and a little bit about the structure of the atom in preparation for Unit 3, which will have to do with just the atom itself. Okay, measurement. And when we make scientific measurements, we use the metric system. It's the international way of describing different quantities in science. Some years ago, the U.S. tried to convert over to the metric system, and it was, had a lot of resistance to that. And probably the only thing left over from that push was the 2-liter bottle. And so people kind of have an idea or a reference of what a liter of liquid looks like, and certainly 2 liters. And then students get a really firm grasp upon the metric system when they get into school and take science classes, because we stick to the metric system in science class. SI units are an important part of the metric system. They're called Systems Nationale, and these base units, or these standards of measurement, are kept in France, and it's an important way of having a standard that everybody uses when they're making these scientific measurements. It's super important to be consistent, and so they have the standards that everybody uses to make up their equipment while they're doing measurements. Probably the only thing that's a little bit different in the base units and the SI units is mass. Mass, we say the base unit for mass is the kilogram. That's the SI unit, but we use the gram as our base unit. Grams, 1 gram of a substance is quite a bit of a substance, and so we switch over to grams because it's a slightly smaller subset and is easier to work with as our base unit. Volume. A liter is the amount of water that at a certain temperature that will fit a 1 decimeter cubed container. And so they have a certain temperature that they keep the water at, because, as you know, water will expand and contract when heated or cooled. Continuing on with our base units. Length. The length of a meter stick. And that's kind of funny because, well, how long is that? Well, back in the olden days when they were measuring lengths of things, they said, well, it's about the size of the king's arm. It's from his tip of his nose to the tip of his fingers. And of course, that's not a very accurate type of measurement, because different people have different wingspans or different size arm lengths. And so they have a bar, or they used to have a bar in France, that is exactly a meter long. Of course, they divide it into smaller parts and that kind of thing. We'll talk more about the prefixes later. But now they actually shoot an electron across a distance, and they measure that distance, how far that particle travels in a certain length of time. So it's more sophisticated even than keeping a metal bar there. Second is the time interval that we use as our base, and then amount is the mole, which is 6.02 times 10 to the 23rd objects. Atoms, formula units, particles, anything that you can think of is a quantity in science. And so a little later on we'll talk about this important mole concept and why we need such a large grouping to hold those very, very small particles. So these are our base units. Of course, with the base units, we need to make them either larger or smaller depending on the quantity that we're dealing with. So like if we were going to measure the distance between here and, I'm in Bowling Green, Kentucky. So if we were to measure the distance between Bowling Green, Kentucky and Nashville, Tennessee, we want to do it in meters, because you'd have a ton of meters. You'd have a very large number. And so we multiply that out and we call it a kilometer. And so 1 kilometer is equal to 1,000 meters. And so we use prefixes to either make them small or larger. If you were to measure like the width of a hair, you certainly want to measure it with a meter stick. You'd want to have a smaller division, and maybe even smaller than what we talk about. We talk about milliliters. So these prefixes either make the units smaller or larger. And I'll put these up here and we'll talk about them. So the ones on top of the base units here, the ones on, oops, get that right. The ones on top of the base units here, the kilo, the hecta, the deca, are larger than the base units. And the metric system's all based on units of 10. So you have 10, hundreds, thousands greater than the base units. And then you got a tenth, a hundredth, and a thousandth smaller than the base units. And I have a little saying that helps me remember the base units. I say, kids have died over drinking chocolate milk. So that's the one that I started with, and then my kids start to gripe and complain and said, well, that's not very descriptive, because you can't really die drinking chocolate milk. And they said, well, doing metric conversions is difficult, and so we're going to say kids have died over doing conversions metric. Okay, so that's another way of figuring it out. And then I had a really rough group of kids at one point, and they said, no, you can't die over doing conversions metric. You might make a bad grade, and so what if we make a bad grade? But let's say that, let's make it really descriptive of what can actually happen. So they said kids have died over doing crack and meth. So I thought that was pretty ingenious way of looking at it too. So to review the slide, we say that the units on top are the larger base units, or multiples of the base units, and then the ones on the bottom are divisions of that base unit to make them smaller indeed. Metric measurements and significant figures is the next big topic, and we'll talk about the metric conversions and that kind of thing first, and then we'll do a separate slide on significant figures. We'll try to hold to significant figures as we're doing our calculations, and then you can kind of go back and see if I did it right once you know about the significant figures. Okay, metric measurements, prefixes are used to divide, we talked about, into smaller fractions or to multiply to make larger. The divisions and multiples are always in units of 10. An example, we did talked about that, is 1 kilogram is 1,000 times larger than a gram. Now, a milliliter is 1,000 times smaller than a liter. So 1 milliliter is equal to 1,000, or 1 liter is equal to 1,000 milliliters. We call these conversion factors when we're talking. This is a conversion factor, and this is a conversion factor. A conversion factor does not change your answer at all. It just changes the units from one to the other. So now we are going to talk about making metric to metric conversions using the factor label method. And I'm going to go very slow, and I'm going to make sure that you get this part of the discussion. It may seem a little tedious to you or a little slow, but this is super important to learn this factor label method, because we'll not only be making metric conversions using this, but we'll also use it later on to make chemical conversions, and more complicated conversions at that. So let's talk about the steps to making these type of conversions. The first step says to first underline the unit that you're solving for. And I think it might be helpful as we go over the steps to actually look at an example problem. So let's do that. So we're going to write down here, so there's our example problem. And it says first underline the unit that you're solving for. So that will be grams. To solve for unit will just have a letter or a descriptor by it. It won't have a number. And then it says second, write down the number and the unit you are given. The given will always be a number and a unit. So here we're given 2,000.0 milligrams. So we've taken care of the first two steps. Then it says third, write the conversion factor with the given unit on the bottom of the conversion factor. Okay, so a conversion factor looks like a field goal. Something like that. All right. And it says with the given unit on the bottom. So we're given milligrams, so that goes on the bottom. And then it says place the unit to solve for on the top. So we're solving for grams. So we're solving for grams. Okay. Okay. Fourth, put a 1 next to the larger unit. Well, how do you know what's the larger unit? Well, you can look at your metric prefix chart. Kids have died over doing conversions metric. So we've got grams, liters, meters, and seconds here in the middle. Okay. And so we've got grams, which is a base unit. Base units always just have one letter. And then we have a division of grams called milligrams. So notice here that grams are on top of milligrams, so they're the larger unit. They'll get a value of 1. And then it says here, next step is to put a 1 on the smaller unit. Fifth step here, put a 1 on the smaller unit plus the number of zeros, or that should read, or factors of 10, you count it. All right, so you don't count where you start. We won't count the grams here. We won't count those, but we'll count down to milligrams. 1, 2, 3 steps. So from decigrams to centigrams to milligrams is 1, 2, 3 steps. So you put 3 zeros here. 1, 2, 3 zeros. Okay. And then the sixth step, which is on the next slide, you multiply across the top and then you divide by the bottom. So this will be 2,000 times 1 divided by 1,000. And you got it. You'll have 2 grams. Milligrams cancel. And so you'll have 2.000 grams. Let's see how many significant figures we had in our given. We had 1, 2, 3, 4, 5. So we need to have 5 significant figures in our answer. Don't worry too much about that. We're going to talk about that later, and I'll explain in detail why that is. 1, 2, 3, 4, 5 grams. Okay. And so there is your answer. So let's do a couple more examples on the next slide. Okay, so sixth step, it says multiply across the top and divide by the bottom. Don't forget your units on your answers. So let's do these 2 problems. So it says how many hectograms are in 200 grams. Okay, so the first step is to underline what you're solving for and write down a given. So we're given 200 grams. And then we write a conversion factor with the given units on the bottom, which are grams. Notice here, that's our given unit. And then we have hectograms on top. So now we've got to decide what is bigger, a hectogram or gram. So we look at our chart again, kids. We've got grams, liters, meters, and seconds here in the middle as our base units. And we have hectograms this time and grams this time. So here we notice that hectograms are the bigger unit. So they will receive a value of 1. And then we count from hectograms down to grams. There's 1, 2 steps, right? 2 steps, so we have 2 factors of 10 or 100. And then, so grams will cancel. And 200 times 1 divided by 100 gives us 2 hectograms. Here, since we don't have a decimal, we just got 1 significant figure in our problem. All right, let's work another one. We've got 0.5 deciliters, and we're converting those to milliliters. First step's underline what you're solving for. Second step is to write down your given. 0.5 deciliters. All right. And then do our conversion factor. Whatever we're given goes on the bottom, deciliter, so it'll cancel out at the end of your problem. And we're solving for milliliters. Okay. So here we have milliliters all the way down here. And we have deciliters, which will be right here. Okay. So we have the bigger unit, which is deciliters, will receive a 1. Right. And now milliliters will receive a 1 plus some factors of 10 that we determine by counting. So we go 1 step, 2 steps down. So we'll have 2 there. All these had 2. I should have made it a little different. But we have 0.5 times 100. So that will end up giving us 0.5 times 100 divided by 1, which will give us 50 milliliters. I hope you found this interesting. We'll have additional practice problems for you to do using this factor label method along with solutions, so you can check your answers to make sure you're doing it correctly. And then on to the next unit.